Okay, we're going to go ahead and get started on this intro to Vault. If somebody can kind of ping me in the chat if you can hear me okay. Okay, thanks, Alec. So we'll go ahead and we'll get started. All right, so today we're going to talk a little bit about Vault. First of all, let's talk a little bit about me. So I'm Corey, principal engineer here at Cabbage. Been here for about 6 years. Mostly work on kind of design and prototyping, kicking off new projects, that kind of thing. Some recent stuff has been kind of our first foray into Kubernetes, doing some work with Terraform, and also some stuff with Vault. So it's a quick note about this presentation. This is going to be mostly focused on the developer side of interfacing with Vault, rather than kind of the operations side of it where you're setting up and managing a cluster. More about how do I interact with Vault and get secrets into my application. So let's go ahead and get started. All right, so first of all, what is Vault? So Vault is primarily a tool for secrets management. So what does secrets management mean? So secrets management is about giving us a way to securely store our secrets. So passwords, certificates, anything that's sensitive that we wouldn't want, that we have to have more control over who has access to it, and we want to make sure it's not leaked if there's ever a data breach or something along those lines. It also lets us restrict access to those secrets. One of the really cool things you can do with Vault that you can't do with some of the other secrets management tools is dynamic secrets. So this lets us create credentials or certificates, things like that, on the fly and revoke them when they're no longer in use. So why would we want to use something like that versus just having somebody generate passwords and put them in here as static keys? So some of the benefits are it keeps those secrets very short-lived if you want them to be. So that way if somebody were to compromise a set of credentials, maybe they're only good for 30 minutes or something like that, which means they're less likely to get something sensitive with those. It also lets us centralize the management of all of our access policies. So because the credentials can only be procured through Vault, then you have this centralized place where I can go and I can look at who has access to what. And there's also audit trails in Vault, which can help with that as well. It has some features that allow kind of what they call a pattern of like encryption as a service, where you can give it essentially just arbitrary data and it can encrypt it for you. It'll store the keys in Vault, but not the actual data. The idea is you would use this to encrypt fields in your database or something like that, where Vault does, you don't necessarily want to put it in Vault because there's a lot of different data, or it's linked to customer records you already have in that database. So why would you want to do that? It's really just because encryption is hard. Like the standard advice is don't roll your own crypto. So in this case, you can delegate to Vault and let it take care of all of the cryptography, the keys. You can do key rotation, all that kind of stuff. And you just worry about your application logic and how to store that data wherever you want it. You don't worry about how to make it secure. So first part of interacting with Vault. I forgot one piece on here. So how do we interact with Vault? Vault has an HTTP API. Standard kind of RESTful style API. There's a CLI tool built into the Vault command line, or the Vault executable, that just sits on top of that API, but provides some convenience functionality on top of that. And then there's also a web UI, which just recently got included in the open source version. So interfacing with Vault. So the first thing you have to do is you have to get a token. So the token is what we use to authenticate with Vault when we make API calls. One of the, you send it to Vault using a header. It's the XVault token header. One of the interesting things with tokens is they have a lease associated to them. If you're familiar with a DHCP lease, it's very similar to that. The idea is when I get a token somehow from Vault, you have a lease, and that lease has a timeout on it, and I must renew that lease every so often, and that will extend that timeout. So the useful thing with this is that if a token stops being used, say it was retrieved by an application and the application crashed or it shut down or something like that, the token will automatically expire without the application needing to do anything with it. So it simplifies your life a little bit there in terms of you want to have short-lived tokens so that if somebody does compromise them, you're not exposed any more than you have to be. You can also revoke those explicitly if you want to. So if you did want to handle that in your application, you can. The tokens also generally have an associated TTL, so time to live, which beyond that they're no longer valid no matter how many times you try and renew it. You can't renew it beyond that TTL. Maximum for that is like 32 days, I think. So beyond that, another kind of core piece of Vault that you need to know about is policies. So policies control what your token is allowed to access within the Vault API. So it's associated with a token at creation time. So what that means is basically based on how you're getting your token, you get assigned different policies. If you change what's assigned to that authentication mechanism, that obviously doesn't change for any tokens that have already been granted. But if you do change the things inside of the policy, those do get applied and validated real time. So those changes would automatically get applied. The policies are a document written in HCL or JSON. HCL is HashiCorp's configuration language. It looks similar to JSON with less syntax, essentially. Everything in there is denied by default, so if you have a completely empty policy, you can't do anything. But you can also explicitly deny operations, but generally what you're going to do is just allow different operations. So what you allow based on is the API path or a path prefix. So you can put a wildcard character at the end of the path, and it's just everything beyond that. It doesn't support like traditional globs where they can be in the middle. It's only at the end of the path. You also specify the operations that you're allowed to do. So those generally map kind of one-to-one with HTTP verbs. So there's like create should be your post, read, get, update, put, delete, and they also use the list verb for operations that list things rather than just straight up get. You can also restrict things based on the parameters in the API request. Won't really go into that a whole lot, but you can even further restrict it based on those. So, secrets engines. So this is where we actually store our secrets or retrieve them. So they're pretty varied in functionality. So the most straightforward ones store and retrieve static secrets. So you tell Vault, hey, I want to store password X, and then at a later time I want to retrieve it. That's the most straightforward stuff. There's also the dynamic secrets, which can generate users on the fly. There's also dynamic engines that they don't create users, but they'll rotate the password for an existing user for you, for systems where you may not want to actually just make new users. And then, like we talked about, you can just encrypt arbitrary data. Most secrets have leases, just like the tokens do. Generally, the thing that's an exception to that is static secrets. Obviously, like you can't revoke them because they're not controlled by Vault. Most secrets also have a TTL, just like tokens. Same kind of deal. So the lease, you must keep renewing it to keep using it, or else Vault will, if Vault created a user, if you let the lease expire, it'll go and it'll delete the user. And at the end of the TTL, it will also just go delete the user because you can no longer renew it. So let's talk about some of the secrets engines in a little bit of depth. And we're just going to kind of cover a couple of these. Those are mostly the ones we're using at Cabbage right now. So key value is the most straightforward one. This is just store arbitrary data. You basically have a path, and at that path you have a set of keys and values. There's two versions to the secret engine at this point. There's a V1 and a V2. V2 stores history is the big difference. The APIs are slightly different between them. So if you have code that works with V1, you do have to make changes to make it work with V2. It's mostly just some of the paths are a little bit different. A lot of the client libraries will kind of abstract that away from you, though. Configuration-wise, to enable this, basically you have to go and you have to enable the backend. So all the secrets engines have what's called a secrets engine backend. So you have to go in and you have to enable it, and then you just write your secrets into it. That's really all there is to configuring this. So you can do this via the command line or the API or the UI. And then if you have an app that wants to use it, really all you have to do is you have to authenticate with Vault, and then you just retrieve your secrets. Very straightforward. So let's talk about some of the dynamic ones. So the database secrets engine. So it can automatically generate and revoke database users for you. This supports multiple different database providers. The current list is Cassandra, Influx, HANA, MongoDB, MySQL, MS SQL, Postgres, and Oracle. You can make your own custom one. Vault does have a concept of plugins that you could use to generate your own if you're using some other sort of database. Basically, the configuration for this, you give it the statements. Generally, like if you're using a SQL database, it's your SQL statements to create and revoke the users. So configuration for this, you have to enable the database backend, just like we did the key value. Then you have two parts you need to do. You need to configure the plugin and the connection to the database. So this would be, I'm going to tell Vault, hey, I want to use Postgres. Here is the connection string to my Postgres database. And here are the credentials I want you to use to manage my users in there. So you must give it credentials that are able to create new users and grant them whatever access you want it to do. So what that's going to look like is going to vary based on what provider you're doing. But yeah, generally you have to give it access to a more privileged user. One of the neat things you can do with this, though, is you can give Vault those credentials, and then you can actually have Vault automatically rotate those credentials for you, so that you, again, those credentials are not exposed either, since they're more risky. The other thing you have to tell it is what whitelist of roles that are allowed to connect to it, and that's the next part of the configuration, which is you create roles and associate them to the database connection. So it's kind of like you have a kind of a circular reference here, and it's really just for security purposes in case a different team is maybe creating the database connection part and another versus the team creating the roles that are connecting to the database. So when you create the role, basically you're going to give it, you have to give it at minimum a creation statement, which is going to tell it how to create the user. You basically just give it a SQL command with placeholders for the username and the password filled in. You can also give it a renewal and a deletion statement. Those generally have defaults. It really depends on what you're doing as to whether or not you need to set this. So the default deletion one just deletes the user. If you want to deactivate them for some reason instead of deleting them so that you can audit them later or something like that, then you can change that statement. The renewal statement comes in useful. It's useful for if you're using, say, Postgres, which supports the concept of I have a set of credentials that have an expiration date. You can set the expiration date in your creation statement and then update it every time the renewal statement runs. Next secrets engine is AWS. So this engine will automatically generate and revoke IAM credentials. There's a couple of different kinds of credentials it can generate. It can generate your traditional IAM users. It can also generate, it can give you temporary credentials that are generated by assuming a role, or it can act as a federated identity provider. Just creating IAM users is the most straightforward one. So that's generally what we're using right now. You set the access control policy. Well, you control the policies for what it's allowed to do by giving it an IAM policy document when you configure it. One thing to note with this in general is IAM as a service is eventually consistent. I know this has bit us a couple of times, but if you ask Vault for credentials, they may not work with all services immediately. They take a little bit of time to propagate through AWS's environment before they actually work. So configuration for this, again, enable the backend. Then we configure AWS root credentials. So these have to be credentials that have the ability to create new IAM users or assume the role that you want to give credentials for, or work with the federated identity provider stuff. And then you again create a role that's associated to that, and that's where you actually would specify the IAM policy that this user is going to get. I forgot, I skipped the usage part on the database stuff. Let me go back to that real quick. Real quick on the database stuff. How do we use these credentials? You basically do the same thing. You log into Vault, and then you ask it for the database credentials, and it'll give you back a username and password, and then you have to renew them before your lease expires. The AWS stuff works basically exactly the same. You retrieve IAM credentials from Vault after logging in, and then you need to renew them before the lease expires. Otherwise, Vault will go and it will delete your IAM users behind the scenes. All right, so we talked about secrets engines and we talked about tokens, but how do we get a token? So the most straightforward way is you just can ask Vault to generate tokens and you could hand those out. But the problem with that is now I have to distribute those tokens to my application somehow. So now I have a new secrets management problem. So Vault provides a set of authentication methods that you can use to get Vault tokens where you don't have to use a pre-existing Vault token. So you have to enable them and configure them before you can use. And generally, the way they work is either the thing wanting to get a Vault token, you either provide some sort of kind of static credentials, or you provide essentially proof of identity from a third party. So static credentials would be something like a username and password. It can integrate with Okta or LDAP. There's a thing called app role, which is kind of like a username and password, but it's more focused on if you're going to give them to an application, so they're not they're like GUIDs essentially. Certificates are another option. So the downside is, in all of these cases, you still have to distribute these secrets somehow. And so you have a secrets distribution problem now that you still have to solve. The proof of identity providers are a lot nicer if you can use one of them. So the idea is I'm going to trust AWS or GitHub or Kubernetes or something like that, and I'm going to validate some sort of proof of who I am with those and link that into a set of access policies inside of Vault. So this works with basically all the cloud providers. So I think like AWS, Azure, AliCloud, Google, basically all the cloud providers are supported. Kubernetes, you can do it with service account tokens. You can use GitHub API tokens. And so yeah, the upside to this is you don't generally have to worry about distributing secrets anymore because these things are generally something you can get from your running environment. So let's talk about one of the simple ones first. We'll talk about app role. So app role, you basically have an app role ID and you have a secret ID, and that's what you're going to use for your authentication. So to set this up, you have to enable the auth method, similar to our secrets engines. You then create a role, which you have to give it a name. You give it the set of policies that are going to be associated to tokens that it generates. You can enable or disable the requirement for a secret. So if you want to, you can have it so just the role ID is enough to get a token. You can set the TTL for the token. You can set the lease time for the token. You can set the number of times a token can be used. So if you wanted to use this to essentially give somebody a token that's can be used once, essentially, like then they can use the role ID one time and then it's no longer valid. You can do things like that. There's a whole bunch of other restrictions you can place on these that we won't go through, but because they are static credentials, there's a lot of things to allow you to lock these down if you need to. After we've created the role, you need to retrieve the role ID. Why do we have to do that separately from just creating the role? It's because, like I said, you can use the role ID as the only secret piece that you're giving to get your token, so that's not given back to you by default. And you can generate a secret ID that goes with the role. So the role only has one role ID, but it can have multiple secret IDs associated with it. And then to use this, all you do is you log in with the role ID and the secret ID. So you present those two to Vault. Vault will give you back a token, and then you can make secret or calls to the secrets engines using that token. So the Kubernetes auth method. So this is one of the ones where we don't really have to worry about distributing tokens or anything like that to anybody. So what you do with this is Vault will validate a service account token that you present to it via the Kubernetes API server, and it'll give you a token if it determines it's valid. So to configure this, you enable the auth method, then you configure the connection from Vault to your Kubernetes cluster. So you have to give it the URL for the Kubernetes API. Generally, you give it the CA cert used to connect to the cluster. This is stuff that you would find like in your kube config. And then you give it a service account token optionally. You don't have to do this. And that token has to have very little privileges. They provide the RBAC roles for you if you want to do this. It basically has to have access to, there's an API inside Kubernetes that lets you validate a token, and that's all it does. If you don't want to do that, you have to grant all the service accounts you're going to use to authenticate with Vault access to that API instead. So it's kind of your two options there. Then you create a role inside the Kubernetes auth backend. And this is, you essentially associate a service account and or a namespace that your application is going to run in to a set of policies inside of Vault. So kind of a best practice here would be every app gets its own service account, and then you can give it granular Vault policies that only grant access to whatever that application actually needs access to in Vault. You can also set the lease TTL and the token TTL when you create these. So to use this within your pod, you access the service account token. So the most straightforward way to do this is you actually create the pod with a service account associated to it. And then by default, Vault will mount the service account's token into a volume in your pod. And then you can just pull that out and pass that to Vault, and it'll give you back a token. And you also have to set the name of the role you want to authenticate with. AWS auth method works very similar. So instead of the Kubernetes service account token, you use IAM credentials to validate your token. The interesting thing here is you don't actually give Vault your actual secret. You use the traditional AWS signing methods where you sign a request with your secret to actually get your tokens. There's also like an option to do this with, there's essentially two parts of this. You can either use IAM credentials or you can use some stuff that's in the EC2 metadata service. I'm not really going to cover that because it's generally not recommended anymore, but there's some interesting things you can do with that. So if you want to, you can read the documents on that. To set this up, you enable the AWS auth method, configure AWS credentials for Vault to use. These have to be able to create IAM users. So again, these are highly privileged users. Or no, it doesn't. These don't have to. You configure it with access credits for Vault. These are actually not privileged users. They have to be able to access basically a few of the IAM endpoints to be able to validate who a token is. So they give you an example policy for that, but it's pretty low what you need to give it access to. And then you give it, create a role, which again, you're going to link generally either an IAM user or an IAM role to a set of Vault policies. So to use this, again, you get your IAM credentials. So the most straightforward way to do this would be if you're running in EC2 or running in Lambda. There's generally an API endpoint within your running environment that you can hit to get access to temporary credentials. So this would be like in EC2, it's your EC2's instance role. You get credentials that are allowed to assume that role. So you can pull those credentials out from your runtime environment, and then you can use it to sign the request that you need to send to Vault. Doing this stuff, signing that request, is relatively complicated, like all things involving AWS's signing methods. So the Vault CLI and a lot of the client libraries can kind of take care of that for you if you don't want to deal with that complexity. All right, so all that stuff sounds a little bit complicated, right? Like all the authentication steps, there's a little bit of hoops you have to jump through. Also, keeping token leases and secret leases alive is kind of a pain. So you need to run like a background thread or something like that. So Vault has this great thing. This is relatively new. Came out with kind of like the 1.0 version at the end of last year, and they've added a few things in the last month or so. So you can now run Vault in what's called agent mode, which makes your integration with Vault significantly easier. So the way this works is you run the Vault binary, same one you would use to do the command line tools, same one you would use to run the server, as a client daemon on your client machines where your application is actually running. You have to configure it to do a couple of different things. So the first thing they added was the concept of auto auth. So what this will do is it'll take care of getting your Vault token for you. So this works. It works best in those situations like the AWS or the Kubernetes situation, where you're able to pull the credentials you need out of your running environment. So if you're running in AWS, really all you have to tell it is what role you want to assume, and if you want to use the IAM or the EC2 option. And it is smart enough to it's smart enough to say, hey, I'm going to try the AWS metadata API to get credentials, or I'll try for the standard AWS environment variables to get credentials. It'll try all of those things for you, and as long as it can find credentials, it'll send those off to Vault, or it'll send the signed request off to Vault, and it'll get a token, and it can drop that for you in a file. The other cool thing it can do is it can keep that token alive, so it'll handle the renewing of the lease of the token. And it's even smart enough to say, okay, I've reached the TTL for this token. I will go ahead and I'll get a brand new token from Vault, and I'll write it into the file for you. So the only real complication with this is obviously if you have an application that's going to run, and it might run during the time period that you're going to reach your max TTL, you need to be able to watch that file for changes so that you get a new Vault token. So the other new thing that they've added very recently is caching proxy support. So instead of calling the Vault API directly, you talk to this local agent instead, and it exposes the same API as Vault plus a couple of extra endpoints to manage the actual cache. The cool thing with this is it can go ahead and it can add that auto auth token to all the requests as they go out to the Vault server for you. So you don't even have to worry about the Vault token at all anymore. So it'll take care of it for you. The other cool thing is if you ask it for dynamic secrets, it will cache those secrets for you, and it'll handle renewing the lease for those. So if I asked it for a set of database credentials, the first time it'll go to the Vault server, and it'll retrieve those credentials, and it'll keep track of the lease. It'll keep it renewed, and if I called back to the Vault proxy, the Vault agent proxy again, it'll give me back the same credentials as long as they're not expired. So that makes your life a lot easier. You still need to know to talk to this API to deal with it, but it's taking most of the actual hard parts of dealing with Vault out of it for you. Another tool that we're currently using for some stuff with integrating with Vault is a tool called Console Template, which doesn't necessarily seem like it has anything to do with Vault. But this is an open source tool from HashiCorp, people who created Vault. It was initially built to deal with pulling configurations from console, but it also supports pulling things from Vault now. So the idea is you give it a Go template file, and it will go and it will fetch values from console or Vault, and it'll populate those placeholders into the template file for you and render them to wherever you want. It will not handle getting Vault tokens, but it will handle renewing the lease on any secrets that it does retrieve for you. So it does take care of that. So generally what we are doing when we're running console template is we run a combination of Vault agent and console template together. Vault agent will be in charge of retrieving the Vault token, and console template is essentially in charge of retrieving secrets and putting them somewhere for us. The newer versions of it can watch the token file generated by Vault Agent, so it'll handle that file watcher bit for you. So if your Vault tokens are actually expiring. Another cool thing you can use, we don't use this right now, but you can actually use it to execute a child process and send essentially like a restart or reload command to it when the template changes. So the normal use case for this would be something like, say, Nginx. I would use console template to render my Nginx config file, put it on disk somewhere, and then start Nginx. And then if the config changed for some reason, it can send the signal hang up to Nginx, which would tell it to reload that configuration from disk, so that it's kind of managing that whole life cycle for you. Just look at the chat real quick. Register an endpoint with the agent so it can push changes to the application. So yeah, it would be nice if Vault could essentially push changes to you. We're all kind of, so we, at Cabbage, we do use console as well, and we use it for a lot of it for the key value store for configuration. One of the nice things that that has in it is when you ask console for key values, you can do long polling. So you can tell it, you can essentially fetch a value and it gives you back an updated ID, and you can call back to console and you say, hey, tell me this value if it ever changes, and it'll just block until it actually changes. I kind of have a feeling they may do that at some point with the Vault Agent proxy, because that would make things a lot easier. It kind of fits in with our existing patterns. And that way you would get secrets as soon as they actually update. Cool. So that's the end of the presentation, so let's go into some demos. We got a whole bunch of consoles open here. So, first thing we're going to do is we're going to start a Vault server. So, running an actual Vault server is reasonably complicated. You need to set up some storage for it and things like that, but it has a dev mode, which, scroll back up and scroll through that really quick, that you can start using Vault server-dev. This is a highly insecure way of running Vault, so you would never want to do this in production. For example, the API is available over HTTP instead of HTTPS. The other thing is everything that's in here is stored in memory, and that's it. So everything will just go away as soon as I restart this. But one of the cool things is it automatically puts the root tokens, which is going to be your super privileged tokens here. It's going to put them in a file where the Vault CLI already knows to look for them. So I don't have to do anything to authenticate with Vault now, which is super nice. So the only thing you really have to do is we have to tell the Vault CLI where our Vault server is. So we're running on localhost on port 8200. If you ever forget this, it's in the output of starting the Vault dev server. So we'll do that command. Scroll down to the bottom of here so we can see stuff as this runs. And now we can use the Vault CLI to interact with our Vault server. So we can let's run Vault status first. So Vault status tells us kind of the status of the server. A lot of the stuff is more operational stuff that we won't really worry about for too long, but just this validates that we are able to talk to it. We can also run token lookup, which is going to give us some information about the token we're currently running under. So you can see we have this root policy associated to us. We have an explicit max TTL of 0, which means it lasts for forever, as all root tokens do. So the root token is just a token that has full access to everything, no matter what, never expires. Generally what you do is you use these to set up the server and then you revoke them, because you don't really want to keep them around. There's ways to generate new ones in case you have an emergency for some reason. So let's create a secret. So first we're going to list the secrets backends that are enabled. So the secrets list command, that's going to show us all of the secrets backends that are enabled. By default, there's a couple that come enabled. So the most important one here is the key value. Secrets backend is on by default, mounted at /secret. There's this interesting thing that we won't get too much into, that you can change the path that a secret engine listens to. Just useful to know. For the most part, there's kind of standards for where they normally would be, and things will assume that they're there, but you can override it if you need to. So we have the key value secret engine running. Let's look at the secrets that are in there. So we're going to tell it to use the key value engine to list. So the key value stuff has its own kind of set of command line arguments here, since it's the one you're going to interact with the most with CLI tooling. This abstracts out the stuff around the V1, V2 stuff for us, which is also nice. So we're going to say list all the secrets in the secret backend called secret. So we get an error here because there is no secrets. So let's go ahead and we'll write a secret. So we're going to use kv put and then give it a path to where we want our secret. So like I said, our secret starts at /secret, so secret/mySecret. And then we're going to give it a set of key value pairs. Let's say username is Bob, and password is secret. Very secure. So now we can say vault kv list. And we can see we have our secret there. And then if we want to read it, we can just say get secret, my secret. And then we have our values. Handy thing, if you are using the Vault CLI locally, it does have some tab completion, which doesn't work on this. But there is some tab completion for some of this stuff, so that's handy to know. So we have a secret. That's useful, I guess. So let's get into policies real quick. So there's a Vault policies command. We can list the policies that exist. So by default, you have root, which has access to everything, and then you have a default policy, which you can change if you want. The default policy has a whole bunch of stuff in it. So this is what policies look like. So you have path, the path that you want to grant access to, what capabilities you want to grant access to that on. So if we look through this, basically what this allows us to do is it allows us to renew leases on our secrets. There should be a thing in here as well to be able to, you can revoke your own token and you can renew your own token. So basically by default you get access to a whole bunch of not very sensitive endpoints. So this is a pretty useful policy to just grant along with your other stuff. So let's also look at making a new policy. So we've got a policy here, my policy, that we're going to say you get access to secret/data/everything. So /data is where the actual values for key value secrets are in the V2 endpoints. We're using the V2 secrets backend. That's what's enabled by default at this point. So this is basically saying that I can read the values of every secret within that secrets backend. We're also going to, in a second here, create the database backend. So we're also going to go ahead and say that you have access to the database/creds endpoints, which is where you would get actual credentials from Vault. So put that back on my other screen. Go back to our terminals here. So how do we actually get that into Vault? So you can use the Vault policy command again. We're going to do write, give it a name of the policy, so let's call it my policy, and then you give it the name of a file. So now if we do Vault policy list, we now have my policy exists. So now we need to associate some things to this policy, right? So let's go ahead and enable some new auth methods. So the first one we're going to do is enable the app role auth method. So we enable it. Then we have to create our role. So we're going to vault write auth role slash the name of the role that we want to create. Call it my role. We'll just, for sake of brevity, just define policies we want it to be associated to. So I'm going to say policies equals default and my policy. It's a comma separated list. Cool. So now we need to get our role ID. So we'll say auth read, which is going to do like a GET request from auth app role my role slash role ID. All these endpoints are in the documentation. The documentation for Vault is actually pretty good. So here's our actual role ID. Now we would need our secret, or a secret for this. So to do that, we have to do a post. So we're creating a secret. We do -f because we're not going to actually pass it anything. So -f is just to say like, hey, I'm doing a put or a post with no body. Auth app role my role slash secret ID. So now we have a secret ID. You'll also notice we have a secret ID accessor. A lot of the kind of secret values you get out of Vault also have an accessor associated to them. Those are useful because you can use that to look up the status of those entities without needing to know the actual secret things. You can also use it to revoke things. So like if you wanted to persist this somewhere where you were worried about somebody compromising it, it's okay. So now we have a role ID and a secret ID, which I told you before. That's all we really need to be able to get a Vault token, right? So let's go ahead. We're going to do array to auth app role login with our role ID and our secret ID. You'll see we get a token back here. You can see the duration here. So this is just really high because it's the default. And you can see that it has these policies associated to it. So if we wanted to, we can now use this token to fetch things from Vault. So let's do some other stuff before we do that. So real quick, I'm going to start Postgres in a Docker container so that we can do some playing around with the database backend. All right, so we started up Postgres. If you look at the command line params here, you can see like I started up with the username admin, password admin, and a database called mydb. And I've got it set to log all the statements, and I'm going to show you why here in a second. So let's go ahead and we're going to create a table inside of that database. So we're going to use that Postgres Docker image again, and we're going to tell it to run a command this time. So create table, my table, with an ID and a bar chart of stuff. Password is admin. So we create a table. You can see that executed down here. Cool. So let's turn on the database backend. So we're going to enable the database secrets engine. By default, it's going to be enabled at database. Now we're going to do a big blob of stuff. So we'll paste this in, and then we'll kind of go through what we're doing here. Make this a little wider. So we're going to write to database/config/ the name of our connection. So in this case, my Postgres database. We're going to tell it the plugin name is Postgres because it's a Postgres database. Allowed roles, my role, which is a role we'll define in a second. And then here you see we give it the connection URL. This is our standard Postgres connection string. We have placeholders here for the username and password. The reason you do this rather than putting the username and password directly in the string is this allows Vault to do the rotation of these credentials later for you if you want to. We're going to tell it to connect to localhost 5432, which is where our Docker version of Postgres is running, and to connect to the MyDB database. So go ahead and do that. And we got another big old command line command here. Let's see if I can make this wide enough so it doesn't wrap. Yeah. All right. Now we're going to create our role. So like I said, we're going to name it my role. We're going to connect to the same database connection. We're going to give it our creation statements. So we're going to say create a role, which is basically a user in Postgres called whatever the name is, with the login password of whatever the password is, and it's valid until whatever the expiration date is. And we're going to grant it access to basically do whatever it wants on all the tables in the public schema, and we're going to grant it access to do whatever it wants on all the sequences in the public schema, because we are using sequences as the serial ID value. We set the TTL to be, the default TTL here is the least TTL, so it's 1 hour, and then the max TTL is 24 hours. So this set of credentials, you would have to renew it once every hour, but you cannot use it after 1 day has passed. So, make this not so wide anymore. And so now we have all the stuff we need to be able to get database credentials. Let's ask Vault to get some. So we're going to say read database where our secret backend is mounted. Creds my role. So you can see here we got kind of gibberish username, some gibberish password, and you can see down here where it actually ran those commands that we asked it to when we created our role. So let's use that to actually connect to the database. Oops. So we're going to connect as this user now. Our password is this. So now we're connected to the database, and we should be able to do an insert into my table stuff values. Yo. So we're able to insert, and we should be able to read back from my table as well. Cool. So our user is able to do those things. So that's all fine and dandy. So let's look at one more file here. So we don't really want to write a whole bunch of code to connect to Vault, right? So we want to use Vault Agent. So this is what the configuration file for Vault Agent looks like. So the first thing we need to do is tell it what address that we would use to connect to Vault. This can also be passed in via environment variables. Then we're going to set up the auto-auth stuff. So in this case, we're going to use the app role method. So we're going to use the app role ID and secret ID that we generated earlier. So we just tell it, in the case of app role, you have to tell it where to read those, the role ID and the secret ID from. They have to be in separate files. If you were doing, say, AWS or Kubernetes, generally you're not having to configure a whole bunch of stuff in here. So I think Kubernetes, you have to tell it the name of the role you want to log in with. And that's all you have to do, assuming the service account token's in the standard location, which is like var secrets something something. And then we give it a sync, which is going to be where it's going to put the tokens. So we tell it to write to a file. This is the only available sync right now. And you tell it the path where to write it to. So we're going to tell it to write in the stuff folder /token. We're going to tell it to read the other stuff from the stuff folder as well. And then we're also going to turn on the cache layer. So the only thing we're going to set here is tell it to use the auto-auth token so that it'll automatically append the token to the request for us. We have to set up a listener for the cache stuff to work. We're just going to set up a TCP one, which because we have TLS disabled equals true here, that's going to be an HTTP endpoint. If you had that set to true, this not set to true, then it's going to be an HTTPS endpoint. You have to do some stuff to set up certs or to trust them and set up what port it's going to listen on. So we're going to listen on 8100. The Vault dev server is running on 8200, so they won't conflict here. So let's go ahead and get that server started, or service. So to start the agent, first we need those secret IDs, the role ID and the secret ID, put in that stuff folder. So we have nothing in stuff right now. So we're just going to use the Vault CLI to get the role ID. So handy thing you can do with CLI is you can tell it what field you want to pull out. It's useful for scripts and things like that. So we're saying, read my role ID again back from the API, just pull the role ID field out, and then we'll shove it into the role ID file. Similar deal, we're going to generate a new secret and pop that into the secret file. So if we were to cat that file, it's got a role ID in it, that has a secret ID in it. So we're all set. We're going to start the Vault agent. So run Vault agent and then give it the path to the config. So you can see it started out. It tells us it's listening on port 8100. And if we actually look through here, you can see started the auth handler, it's authenticating, and authentication was successful, sending the token to syncs. So if we go in here and we look in stuff, there should be a token file with a token in it. You also notice it deleted the secret ID file because you don't generally want files with secrets laying around on disk. So it's kind of handy. So now that we have that up and running, you don't necessarily need to use the Vault CLI because we don't need it to do the work of adding tokens to our request anymore. So let's just use curl and hit port 8100 U1 database. Now let's actually pull the secret first. Secret data my secret. So you can see, let me actually do this. Type to JQ. So we can see we're now able to make API requests without passing any sort of credentials to Vault. If we look up here, you can see it's got received a request to v1 secret data my secret, and it forwarded the request to the server. It did that both times because it doesn't cache static secrets, so there's not really a whole lot of reason to do that. So let's do the same thing, but we'll ask for database credentials. So v1 database, creds, my role. So you can see we got a new username and password here. You can actually see over here in the Postgres stuff where it ran my create role and granted a bunch of privileges to it. And we can see up here in the Vault agent logs, it received a request and it forwarded the request to the Vault server. So what gets interesting is if we make the exact same request again, you'll notice we get the same username back this time and last time. If we look in here, it just says it received a request, and you'd see like Postgres, it didn't actually do anything. That's because it's serving us the cached credentials now. And in the background, it'll keep those alive for us, which is nice. So we don't have to worry about any of that stuff. So let's see if we can use these credentials to log in. Logged in, select asterisk from my table. And so we can log into the database. Cool. So that's really all I have. That's basically how we would integrate with Vault. Here at Cabbage, we do have some tools, especially on the Kubernetes side, to make some of this a little bit even more straightforward. So if you're interested in learning about that, feel free to get with me after the talk. We are actually hoping to maybe open source some of those in the future. So it does help. It essentially gets us to a point where our applications that we use Vault with in Kubernetes don't have to know that they're dealing with Vault. It's completely abstracted away from them. So it makes it a lot easier to do local development without needing to talk to Vault. So local developer experience is a little bit nicer. So does anyone have any questions in the chat? Okay, I guess I'll take that as a no. There's a little bit of a delay between my recording and the chat. So if anyone has any questions, feel free to get with me after. You can, if you work with Cabbage, you can obviously get me on Slack. If you don't, feel free to hit me up on email, Twitter, any of those things. Thanks for watching.